Over here, we just discuss synthetic division. And synthetic division is a shortcut for long division of polynomials. We're talking about polynomials now. And it's a shortcut that we can use under certain circumstances. But before we talk specifically about synthetic division, I want to convince you that division is a worthwhile process besides just doing division. We use it to solve equations, and we use it to solve equations by using it to factor. So let me start out with something real simple, just so that we understand what's going on. If we take 10 and divide by 2, of course, we get the result 5, don't we? And the way we used to check that in grade school is we'd say, okay, take the number 2, multiply with the number 5, and sure enough, we get the result 10, so that we know we've done the problem correctly. Now, on the other hand, if we were dealing with polynomials, and we took x cubed minus 3x squared minus 4x plus 12, and we divided it by x minus 3, and we got the result x squared minus 4, and what we would know is if we took x minus 3 and we multiplied it with x squared minus 4, we were going to get this result. Now, on the hand over here with the numbers, that tells us that 10 is equal to 2 times 5. And so in a sorts, we've actually factored 10 by doing a division by 2. And why would we do a division by 2? Well, we would be looking for a factor of 10. We would look for one factor and we'd figure, oh, well, 2 goes into it. Well, over here, we've done a division. And so from this division, we've got the fact that x cubed minus 3x squared minus 4x plus 12. Because of the division, we know that it's x minus 3 times x squared minus 4. Furthermore, we know how to factor x squared minus 4. That's x plus 2 times x minus 2. So by doing a division, we're actually able to factor that complicated polynomial. And we may have been able to factor it another way. I'm just making an illustration here. Well, that's pretty significant. But the question becomes again, well, how did we know to divide by x minus 3? And that becomes a big issue later on. But for now, let's just suppose we knew to try to divide by x minus 3 and see the result. Okay, so that's the idea of why, and by the way then, see, let's carry this a little bit further. If we were asked to solve, x cubed minus 3x squared minus 4x plus 12 is equal to 0, because of what we've done above, we say, oh, well, that long polynomial in factored form is x minus 3 times x plus 2 times x minus 2 equal. And so we have an equation where that's equal to 0. And then we could set each of those factors to 0, and we would get the solutions, what, x equal 3, negative 2, and positive 2. So the process of factoring is how we solve some equations. And the process of division is how we can do some factoring. So that's the reason we want to spend some time talking about division, and then specifically synthetic division, because it's a shortcut. Well, let's take a division problem. Okay, let's take a division problem. Let's divide 5 into 47. Because the next thing I'm concerned about is how we might write our answers. Okay, so we say, oh, 5 doesn't go into 4, but it'll go into 47, won't it? It goes into 47 9 times. 9 times. Whoops. And so 9 times 5 is 45. And then we subtract, and we get 2, and 5 is bigger than 2, so it won't go into 2. So we have a remainder of 2, don't we? Now, at one time we might have actually written this. The division is 9 with a remainder of 2. Now, let's talk about how we might write this. What we've done is we've taken 47 and divided by 5. Now, of course, that's a fraction. We call the numerator the top part, the denominator the bottom part, but when we're thinking of it as a division problem, we call what we're dividing by the divisor, and what we call what we're dividing into the dividend. Now, in this case, we got a result of 9 with a remainder of 2. And we would normally write that 9 and 2/5. See, that's what we would normally write, 9 and 2/5. But let's recognize that really means 9 plus 2/5 more. Now, let's look at what we have here. In this case, the result of our division is called the quotient. Now, sometimes our remainder is 0, but in this case our remainder is 2. And so this part is where the remainder goes. We create this fraction. Whoops, this is the remainder. And of course the denominator of that fraction is our original divisor. So let me write this a different way then, down below. Dividend, what we're dividing into, divided by divisor, is equal to quotient plus remainder divided by divisor. Now, let's go a little bit further. And so here's what we're talking about. The example that we used above, see, here's what we're talking about is 47 divided by 5, is equal to, I just wrote it above, didn't I? 9 plus 2/5. Now, how did we used to check to see whether this division was correctly? Look at this equation of words and imagine multiplying both sides of this equation by a divisor. Well, when we multiply the left side by divisor, then that fraction just becomes dividend, doesn't it? But we've got to multiply divisor to the other side, and so we'll have the divisor, whatever it is, times the quotient. Plus, then we have to multiply the divisor by that fraction, which is remainder over divisor, and that leaves just remainder. Now, if you look at the example that we just did above when we divided 5 into 47, remember the dividend was 47. The divisor is 5, the quotient is 9, and the remainder is 2. And if you recall, this is the way we used to check our division. When we got our division done, we would multiply the quotient by our divisor, and then we'd add the remainder into it. And if we got our original dividend, then we knew that we did our problem correctly. Now, this is actually called the division algorithm. That's what it's called, the division algorithm. Now, let's move away from numbers for just a moment. So what this is going to look like when we're dealing with polynomials is we're going to have some polynomial we'll refer to as f of x, and another polynomial that we'll refer to as g of x, and we're going to do a division. Well, when we're finished with our division, we will have a quotient, and that will be a polynomial, plus remainder divided by divisor. Well, I'm going to call remainder r of x, which could be a polynomial. And of course, our original divisor was this g of x. Or we could say, using this division algorithm, f of x is equal to g of x times q of x, or q of x times g of x. It doesn't really matter. Okay. Q of x times g of x plus r of x. All I've done is multiply through by the divisor. So once again, here we have our dividend. And I kind of ran myself out of space, didn't I? This is the remainder, working backwards. This is the divisor. This is the quotient. And this is our original dividend, what we were dividing into originally. Now, let's make a note here about the remainder, r of x. Well, above, when we're dealing with numbers, the remainder is a number that's less than the divisor, isn't it? Or it could be 0, okay? 0 or less than the divisor. When we're dealing with polynomials, the remainder is either 0 or, now we're talking about polynomials here. The remainder could be a number or a polynomial that it has degree less than what we were dividing by. And a number, remember, is degree 0. Okay, so, or the degree of r of x is less than that of g of x. That's how we know to stop dividing when we're dealing with polynomials. Well, let's look at long division on the next page, just as a reminder of what we've done in the past. I'm not trying to spend a lot of time on actually doing the long division. I'm going to assume that you've done that in the past, and I'll speed through it. And then we'll compare that to how we do synthetic division. Okay, so we're asked to divide x cubed minus 5x squared plus 3x minus 7 by an x minus 2. So the way we would set this up in the long division form, okay, is that what we're dividing into, the dividend, goes under the division symbol, doesn't it? Now, something we'll also remember when we were doing long division at a previous time is we wanted to make sure that the polynomials were all in order, standard order, that is highest power to lowest power. And we also wanted to make sure that every power was represented. That is, if we were missing x squared, we put a 0x squared in its place, so we had more or less a placeholder for it when we were doing our division. Okay, so we've got it set up. Then we compare the x that we have here to the x cubed that we have here, and we ask ourselves, how many times will x go into x cubed? But an easier way to say that will be, what do we multiply x by to get an x cubed? And that's x squared. And so we have a column of x squareds, and so we put the x squared there. Now we turn around, though, and we use this x squared to multiply the whole divisor, x minus 2. And so to do that, we say x squared times the x, that gives x cubed. And then we have, say, x squared times the minus 2, and that gives a minus 2x squared. And then we do our subtraction. And let me remind you, we're taking the top polynomial and subtracting the bottom. And so we kind of look at it like this. We're going to take that x cubed on top, and we're going to subtract, see the subtraction's out here. We're going to subtract the x cubed that's on bottom, and of course that gives 0. And we don't put a 0 in the beginning. Then we're going to look at, we have a minus 5x squared on top, and then we've got our subtraction, or again, which is out here. And what are we subtracting? On bottom, we have a minus 2x squared. And when we do that subtraction, that's negative 5x squared plus 2x squared, which is a negative 3x squared, isn't it? And so we get a negative 3x squared in this position when we do that subtraction. And then, of course, there's nothing to subtract from the 3x or from the minus 7, so we bring those down. And then we start the process over again. This time we say, how many times will x go into negative 3x squared, or what do we multiply x by to get a negative 3x squared, and we multiply it by negative 3x. So now we take that negative 3x and multiply the whole divisor. Negative 3x times x is negative 3x squared. Negative 3x times a negative 2 is a plus 6x. And then we go through this subtraction again. Negative 3x squared subtract negative 3x squared is 0. But positive 3x subtract positive 6x is negative 3x. Bring down the minus 7. Okay? Now, once again, we're not finished with our division because x will go into negative 3x. See, the x up here goes into negative 3x. We say, what do we multiply x by to get a negative 3x? Oh, a minus 3. So now we take that minus 3 and multiply it by the whole divisor, x minus 2. Negative 3 times x is negative 3x. Negative 3 times negative 2 is plus 6. And then we subtract. Well, negative 3x subtract negative 3x is 0. Negative 7 subtract positive 6 is negative 13. So, and now that the degree of our remainder down here is smaller than the degree of x minus 2, we're finished dividing. So this is the remainder. This is the quotient. And so what did we say we would write this as? Quotient x squared minus 3x minus 3 plus a fraction. And the fraction is the remainder divided by the original divisor, x minus 2. So that's how we could write the result of that multiplication. Now, let's discuss synthetic division. Okay, it's easier to do here. Okay, so the thing about synthetic division is we don't leave the x's in there, we just use coefficients and constants. Okay, so here's what we're going to do. We're going to put an upside down kind of division bar, except I keep it all straight. And every teacher and book maybe does it a little differently, but this is the way I do it. And then we put an extra bar below that. Inside this, we put the coefficients of our dividend. It has to be in the right order. So we look at the coefficient of x cubed, which is a 1, we put a 1. We look at the coefficient of x squared, which is negative 5. We move over here and we put a negative 5. We look at the coefficient of, say, x cubed, x squared, x constant. So we've got everyone accounted for. Coefficient of x is 3, and the coefficient of the constant is negative 7. So we've written the coefficients and the constant in the correct order above. Now, out here we put what's called the synthetic divisor. And we don't put coefficients here. In this case, we're dividing by x minus 2, so the synthetic divisor is 2. Okay? So let's back up before we finish this, okay? Let's look at our normal divisors and refer to synthetic divisor. And that's what we put outside, okay? Synthetic divisor. If we're dividing by x minus 2, our synthetic divisor is 2. It's the number being subtracted from x. See, look, x subtract what? Oh, x subtract 2, so 2 is the synthetic divisor. X subtract a 1/3, the synthetic divisor is 1/3. X subtract the square root of 5, the synthetic divisor is the square root of 5. X plus 2. Oh, there's not a subtraction. So what we have to do is manufacture a subtraction. X subtract what is the same as x plus 2. X subtract a negative 2. So when we have an x plus 2, what's being subtracted from x is a negative 2. So the synthetic divisor would be negative 2. X plus 5. What's the synthetic divisor? Well, the synthetic divisor is negative 5 because the number that we have to subtract from x to see an x plus 5 is a negative 5. Now, this would also tell you that the only types of divisors that are appropriate, see, if we're going to use synthetic division, our divisor must be of the form x minus k. Now that k could be a negative number, so then it would look like x plus, wouldn't it? But we can't have an x squared. We can't have a 3x in front. It has to be x minus a number or x plus a number, and in that case, our synthetic divisor is a negative number. Okay. Well, that's how we decide what the synthetic divisor is. Now, how do we do this division? Well, the very first thing we do is take the number that's here and move it all the way down to the bottom. Okay, so I'm just writing it in that position. Now, a number that's in the very bottom here gets multiplied by the synthetic divisor. So now we say 2 times 1, which is 2. That result goes in this middle row in the next column. So that's this. That was the 2 times the 1 below equal 2, and that's where I put it. Now, here's what we do next. When we have a top row number and a middle row number, we add those together. Negative 5 plus 2 is a 3. Okay? Now, we look again and say, oh, we've got a new number on the bottom. So what do? We multiply those numbers together. Okay? 2 times 3 is 6. I've made a mistake someplace. That's the reason for my pausing here. And I see way back up here, I apologize. Way back up here, at this row, I really goofed, and I hope that you caught my mistake. At this row, we were multiplying. See, we multiplied by a negative 3x. That's true, isn't it? Oh, here's my mistake. My mistake is here, isn't it? What I'm working on below. Negative 5 plus 2 is negative 3, isn't it? Oh, goodness, I about made a silly mistake. Now we have a new number on the bottom. And so the new number on the bottom gets multiplied with the synthetic divisor, which is 2. So now we have a 2 times a negative 3, which is a negative 6. And so that negative 6 goes right here. And then we add the two numbers, 3 and negative 6, and we get a negative 3 again. And now we have that new number on the bottom again, so it gets multiplied with the synthetic divisor, which is the same as a while ago. 2 times negative 3 is negative 6. It goes in this position. And then we add the negative 7 and the negative 6, and we get a negative 13. Now, the negative 13 certainly is familiar to us because above that was the remainder. In fact, this position will always be the remainder of the division. Okay? And these happen to be the coefficients of the quotient. The quotient coefficients in constant. See, negative 3, remember what our quotient was above. It was x squared minus 3x minus 3. This minus 3 is the constant. This negative 3 is the coefficient of x to the first power. And this 1 is the coefficient of x squared. And so we can read the quotient from those numbers below. We have a let's put this back up here now. Looking at those, we have a coefficient of 1, and that belongs to x squared. So 1x squared. We have a coefficient of -3, and that -3 is the coefficient of x. So that's minus 3x. And then we have this constant, which is a -3, and so we just write that down as -3, and that's exactly the coefficient, the quotient that we had above by long division. And then, of course, the remainder, as I said, is always in that last position. And here again, the remainder we get is -13, so exactly the same results we had before. Okay, well, let's look at another problem on the next page, just so that we have another opportunity to do this. Well, this time we're asked to divide 2x to the 5th plus 3x to the 4th plus 25x squared minus 1 by x plus 3. And we've seen, I hope, that synthetic division is pretty easy to do. We just have some interpretation that we have to make sure to do. So the first question that we ask here is, do we have to use long division, or is this synthetic division proper? Okay, is this eligible for synthetic division? And remember, the way we make that determination is we look at the divisor. All depends on the divisor, okay? And the divisor is x plus 3. So that's a good synthetic division type divisor. And so remember, we have to be able to think of it as x subtract a number, and x plus 3 is x subtract a -3, okay? And let me remind you, x squared plus 3 wouldn't be eligible, 5x plus 3 wouldn't be eligible, but x plus 3 is eligible, okay? And I'm trying to make it clear that it has to be specifically 1x, either plus or minus a constant. Okay, anyway, it is eligible for synthetic division, so we'll get ready to set up doing the division. Now, we write down the coefficients of our dividend, what we're dividing into. But we have to account for any missing powers of x. It's already in the correct order, and so the coefficient of the highest power, x to the 5th, is a 2. And then the next power is x to the 4th, the power 4, and that coefficient is 3. And the next power would be 3, x cubed, but we don't have any x cubed, so that coefficient is 0, and we record that. It's important to record that. Then we would have x squareds, and the coefficient there is 5. Then we would have x to the first power, which we don't have, so that coefficient would be 0. And then finally, we're down to our constant, which is -1, -1. Okay. Now, we look at our divisor, x plus 3, and we decide then, since that's the same as x subtract -3, the number being subtracted from x is a -3, so that becomes the synthetic divisor. Then we draw another line to create that blank row, and we bring the 2 all the way down. Okay, so now we say -3, the synthetic divisor, times the 2 on bottom is -6. And then we add the 3 and the -6, and we get -3. And then we take the -3, which is the synthetic divisor, times the -3 on the bottom row, and we get a +9. And then we add the 0 and the 9, and we get a 9. Then we take the -3, which is the synthetic divisor, multiply with the 9 on the bottom row, we get -27. We add the 25 and the -27, and we get a -2. We take the -3, which is the synthetic divisor, multiply with -2, we get a +6, put it in that middle row in the next column. We add the 0 and the 6, and we get a 6. -3 times 6 is -18. We add the -1 and the -18, and we get a -19. Okay, so here is the remainder. Pretty cool. Here are the coefficients, okay, of the divisor. This is always going to be the constant. This is x to the first. This is x to the second. This is x to the third. This is x to the fourth. Whenever, so here's what our quotient is, okay? Here's what our quotient is. 2x to the fourth minus 3x cubed. So I'm just looking above at the coefficients. Plus 9x squared minus 2x plus 6. And of course our remainder, we decided was negative 19. So we could say that when we divide 2x to the fifth plus 3x to the fourth plus 25x squared minus 1 by x plus 3, we get a quotient which is 2x to the fourth minus 3x cubed plus 9x squared minus 2x plus 6 plus a fraction, which is the remainder, negative 19, divided by the original divisor, x plus 3. That's another way we could write that out. Now, here's a note for you to think about. With synthetic division, let me write it out. As I was saying, with synthetic division, and the reason it's true with synthetic division is because of the type of divisor we have. With synthetic division, the degree of the quotient is going to be 1 less than the degree of the dividend, what we were dividing into. See, the dividend in this case had a degree of 5. The quotient had a degree of 4, because it ended up with x to the 4th. That's always going to be the case when we're dealing with synthetic division because of the type of divisor that we have. And, again, and the remainder is degree 0. Well, but hold on. See, we always have, our divisor is degree 1 when we have synthetic division, because it's x minus a number, x plus a number. So our divisor is degree 1. And we divide until we get something smaller than our divisor. So we're talking about something a degree less than 1. Well, a degree less than 1 is 0. And we've seen previously that that means degree 0 means we have a constant, okay? So our remainder is going to be a constant when we're doing, or the remainder 0 is a constant. We actually could have a remainder of 0. Sometimes we say no remainder, but that's still a constant. 0 is a constant. So our remainder is going to be a regular constant like a negative 19, or it could in fact be a number like 0. Well, this should get you started for any problems that you have dealing with synthetic division. And we're going to use synthetic division to solve equations, to factor polynomials, to find x-intercepts. That's how we'll use synthetic division. Good luck.